Today we're going to learn how to use representations of functions. You should be on page 39 in your notes packet. Previously, we've learned that functions can be written in multiple ways. Typically, we see them written as ordered pairs, points on a coordinate plane, in input-output tables, which are the same as XY tables, in mapping diagrams, in equations, and in words. We also want to know about a function itself. So remember that a function is a special type of relation where every input has exactly one output. In example 1, we're going to use the equation y equals 2x minus 3 to show how we can represent a function in multiple ways. Well, the first thing we can do with this is put it in an input-output table. So remember, an input-output table always has an x value and a y value. When you're trying to fill out your input-output table, you always want to start by assigning random values to x. Typically, when I do mine, I always try to give a variation of negative and positive numbers. So I usually start with a number like -2, and then -1, 0, 1, 2, 3. That way I can see how this function reacts with an x value that's negative, an x value that's 0, and with x values that are positive. Now, to figure out what y equals, I need to come back to this equation, which says y equals 2x minus 3. I'm going to plug in or substitute each of these x values that I randomly selected to find the y value. So what I'm trying to find is, what does y equal if I'm telling you that x equals -2? Well, my equation says y equals 2x minus 3. So what I'm going to do is replace my x with -2. So instead of 2 times x, I'm going to say 2 times -2. Then I still have to do minus 3. Well, 2 times -2 is -4. Then -4 minus 3 gives me -7. So when I have an x value of -2, I have a y value of -7. I'm going to do the same thing with all of these. So the next one says y equals -1, or y equals 2x minus 3, but I'm sorry, but I'm using x as -1. So we still use the same equation, but this time instead of 1 or x, I'm going to put in -1. Well, 2 times -1 is -2, and then I'm going to do -2 minus 3, which gives me -5. So that is what I will put in my y value. Then I'll do the same thing, but I'm going to use 0 for x. So y equals 2x minus 3. So instead of x, I'm going to say 2 times 0 minus 3. Well, 2 times 0 is 0. And if I do 0 minus 3, I get -3. So when x is 0, y is -3. Then I will use 1. So we're still using the same equation, but instead of x now, I'm going to put a 1. Well, 2 times 1 is 2, and 2 minus 3 is going to give us -1. Now I'm going to do the same thing, but this time I'm going to use 2. So instead of 2 times x, I'm going to say 2 times 2 minus 3. Well, 2 times 2 is 4, and then 4 minus 3 gives me 1. So when x is 2, y is 3. Then I have to do the same thing with my last x value, which is x equals 3. Well, if I plugged x equals 3 in, I would do 2 times 3, which is 6, and then 6 minus 3 gives me 3. Now I can take all of the values that are in my input-output table, and I can write these as ordered pairs. Now remember, I have listed this as a function, so I'm going to put my ordered pairs inside of brackets. Each ordered pair should be in parentheses, and there should be an x value followed by the y value and a comma. So I'm going to start by looking at each set. I know that when x is -2, y is -7. So the ordered pair that represents that is -2, comma, -7. Then I'll write my next ordered pair, which I'm going to get from here. This says that when x is -1, y is -5. So my ordered pair is -1, -5. Then my next one says that when x is 0, y is -3. So my ordered pair is 0, -3. Next, I have 1 and -1. Then I have 2 and +1. And finally, I have 3 and 3. Notice that all of my ordered pairs are separated by commas, and the whole thing is in brackets to represent that this was all one function together. Now, with ordered pairs, I can take ordered pairs and I can graph them on the number line. So if I have an ordered pair that says -2, -7, that means I have an x value of -2. So to plot that, I would move left 2 units. Then I have a y value of -7. So to plot that, I would move down 1, 2, 3, 4, 5, 6, 7 units, and I would place my point. My next point is at -1, -5. Well, if I started at the origin, -1 means I would move left 1, and then -5 means I would move down 5. And then I would place my point. My next ordered pair is at 0, -3. Well, 0 means that I would not move left or right because my x value is 0. But -3 for a y value means that I would move down 3 units. For 1, -1, an x value of +1 means I'm going to move right 1, and then a y value of -1 means I'm going to move down 1. My next ordered pair is 2, 1, so that means I'm going to move right 2 and then up 1. And my last ordered pair is 3, 3, so I'm going to move right 3 and then up 3. Now I can also take this and I can place this into a mapping diagram. Typically when I make a mapping diagram, I like to make sure that I only list numbers one time, but also I like to list my x values and y values in order from least to greatest. So remember, your first oval represents your x or your inputs, and your second one represents your y or your outputs. Well, my x values are actually already in order from least to greatest. So that's -2, -1, 0, 1, 2, 3. Then if you look at your y values, they are also already in order from least to greatest. So that's -7, -5, -3, -1, +1, 3. Well, when x was -2, y was -7. So I need to show that on my mapping diagram by drawing an arrow from -2 to -7. When x was -1, y was -5. So again, I draw an arrow from -1 to -5. Then I know 0 goes with -3. 1 goes with -1. 2 goes with +1. And 3 goes with +3. For example 2, we're using the equation y equals -4x plus 4 to show how we can represent a function in multiple ways. Again, if we start with our input-output table, I'm going to say that this one is x and this one is y. I always start by just choosing random values to plug in for my x values. So I always start with a few positives and a few negatives. So if I were doing this, I would do -2, -1, 0, 1, 2, and 3 in my x column. Then I'm going to use these to figure out if these are the values that I'm plugging in for x, what would I get for y? So in my equation, y equals -4x plus 4, if I have an x value of -2, then instead of saying -4 times x, I would say -4 times -2, then plus 4. Well, -4 times -2 is +8, and +8 plus 4 is going to give me 12. For the rest of my table, I should get 8, followed by 4, then 0, then -4, then -8. If I take these and write them as ordered pairs, I see that -2 goes with +12, so I would write that as -2, comma 12 in parentheses. Then -1, 8, 0, 4, 1, 0, 2, -4, and then 3, -8. Then I can take my ordered pairs and graph them on the coordinate plane. If my first ordered pair is -2, 12, that tells me that if I started at the origin, I would move left 2, then I would move up 12. And you'll notice that for this, you have to go a little bit off of your grid to get to 12. For -1, 8, if I started at the origin, I would move left 1, then up 8, and I would be right here. For 0, 4, I would not move left or right because my x value is 0, but then I would move up 4 units. For 1, 0, I would move right 1, but then I would not move up or down because my y value is 0, so I would be right here. For 2, -1, I would move right 2, then down 4 units. For 3, -8, I would move right 3, then down 8 units. Now for the mapping diagram, again, remember the first oval represents x, the second represents y. So my x values are already in order from least to greatest. So I would have -2, -1, 0, 1, 2, and 3. My y values are actually greatest to least. So I would flip those so they were also in least to greatest. So -8, -4, 0, 4, 8, and 12. Well, I know that when x was -2, y was +12. So I would come over here to 2 or -2 and I would draw an arrow to +12. When x was -1, y was 8. So I would draw an arrow from -1 to 8, then from 0 to 4, then from 1 to 0, from 2 to -4, and then from 3 to -8. You have one question at the end that says which ordered pair represents the y-intercept of the function and how do you know? Well, the y-intercept is always where your graph intersects the y-axis. So in this case, your graph intersects the y-axis right here. The coordinate that represents this is 0, 4. So we know that it's 0, 4 because this is where it intersects the y-axis. The easiest way to find this, especially if you don't have a graph that you can actually see, is to look at your ordered pairs. You can always find the y-intercept in your ordered pairs because the y-intercept will be where your ordered pair has an x value of 0. Example 3 says a bicycle company charges a $12 rental fee for a bike plus an additional $150 per hour. Write an equation that can be used to represent the cost, y, of the bicycle in terms of x hours. Well, I know that the cost, that's y, is going to be equal to, we know that we have to pay $12 to rent the bike, and we also have to pay $150 per hour. Now, the $12 rental fee is just a flat fee. I have to pay $12 no matter what. The $150 per hour is going to change based on the number of hours that I ride the bike. So this is going to have my variable with it. So I know that it's 150 per hour. So I'm going to use x to represent the hours. So it's 150 times x. or 150 times the number of hours. Now, remember, I also have to pay that $12 fee. So after I figure out how many hours I ride and how much it costs me for riding the bike that many hours, I also have to add the $12 fee on top of that. Part B asks, what is the cost of a rental for 5 hours? Well, all you're going to do here is find the cost. And remember, we're using the same equation, but we know that X is going to be 5. So we're going to substitute 5 in for X. So instead of 150 times X, we're going to say 150 times 5, then plus 12. Well, if we do 150 times 5, we're going to get $7.50. Then if we add 12 to that, we're going to get $19.50. So a rental for 5 hours costs $19.50. Example 4 says a plumber charges $55 to make a house call plus an additional $40 per hour. Well, the $55 is what they charge no matter what. So this is a flat fee. The $40 per hour is where it will vary. So we're going to put a variable with that. So if I write an equation, it's going to be y equals, well, I know it's 40 per hour, so that 40 goes with x. And then I also have to pay that 55 just to be there, so plus 55. Well, what is the cost if the plumber has to work for 3 hours? Well, I'm going to take y equals 40x plus 55, and I'm going to plug in 3 for x. So instead of 40 times x, I'm going to say 40 times 3. And when I multiply 40 times 3, I get 120. Then I still have to add 120 plus 55, which gives me 175. So that means that the plumber would charge $175 for working 3 hours. Number 5 says it costs $8.50 to enter the fair plus an additional $2.25 for each ticket ride purchased. Well, if we're writing an equation, $8.50 is just the flat fee that it costs just to go to the fair, even if you don't purchase any ticket ride or ride tickets. But if you do, then this is how your cost is going to vary. So we're going to put a variable with our $2.25. So we're going to write this as y equals $2.25 times the number of tickets, so times x, plus the $8.50 that it costs just to enter the fair. Well, the next question asks, what is the cost if Jasmine purchases 8 ride tickets? Well, if Jasmine purchases 8 ride tickets, we're still using the formula y equals 2.25x plus 850. Well, she's going to replace the x with 8. So it's going to be $2.25 times 8 plus 850. Well, when we multiply 225 times 8, we get 18. So this is 18 plus 850, which is going to give us a total of 2650. So if Jasmine goes to the fair and purchases 8 ride tickets, she will have to pay $26.50.